Hello, 5th grade. Today we're on lesson 83. The two objectives are to identify geometric solids by their faces, edges, and vertices. We will also describe geometric solids. We'll name them. Already we've talked about plane figures. Those are two-dimensional figures like a square or a circle, a rectangle, a parallelogram, all of those different plane figures that we've talked about. Geometric solids is the focus for today. Those are three-dimensional objects. Three-dimensional objects like a book. Okay, it actually takes up space. It doesn't fit on a flat plane or flat surface. So some examples like the book, that would be a rectangular. Okay, we've got rectangular solid, and there's a table in your book on pages 540. They've got a cube, a rectangular prism, a pyramid, a cylinder, a sphere, and a cone. We'll label them today. We'll talk about, again, vertices and edges and all that good stuff too. On this page, I'm going to draw a cube. Okay, and the lines that I've drawn that are dotted lines, okay, those are just hidden lines for this three-dimensional object. Obviously, you can't draw a three-dimensional object and have it on a two-dimensional surface. So that's why we have what we have. Where two sides meet, right here, that's called an edge. An edge is where two sides meet. And this is an example of an edge. This is an example, and of course all of these lines are. Where three edges meet at a point, that's called a vertex. And the plural will just be vertices if you have more than one of them. And then finally we have faces or surfaces. Okay, the flat face or surfaces, those include this entire area right here. And those are called, it's called a face. Okay, let's look at example number one. Example number one. Okay, it gives us a rectangular face. Okay, and it says name the shape at the right. Okay, and this particular shape is named a rectangular solid or a rectangular prism. Okay, it says how many faces does it have? Well, we're going to count and I'll cross them off. Okay, so this front face is here. We've got the left side is 2, the right side is 3, top 4, bottom 5, and then we've got the back side. So this rectangular prism has 6 faces. Example number 2. Example number 2 says, what is the shape of a basketball? If you aren't sure, you can, of course, consult the table that we're given. A basketball is perfectly round in every way. I don't know if I can even draw one. Okay, looks something like that. A basketball, the name for its shape is a sphere, and that'll go on example number 2. Example number 3. Okay, this particular shape has 4 triangular faces that meet at a point, and then the base is a square. Okay, this particular three-dimensional object, this geometric solid, is known as a pyramid. Okay, and if we wanted to count faces, that's another thing that they're going to ask us. Faces, we've got one square base, we've got one square face, and we've got 1, 2, 3, 4 triangular faces. And that gives us a total of 5 faces. If they asked us to find vertices, how many vertices does this have? Well, 3 or more of these edges meet here, 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 and then at the top. So it also has 5 vertices. Okay, and if we want to count edges, do that with another color. We've got 1, 2, 3, 4, 5, 6, 7, 8 edges. For example number 3, the only answer that you need to write down is pyramid. Okay, I would like to do a practice problem. Nope, looks like we have one more example. Sorry. Example 4. What it has, it says name this shape and identify its congruent parts. It's got a circle on both the top and the bottom. And it's connected with a rectangle that, if you could imagine a piece of paper, and you take that paper, this rectangular face, and you just round it. Okay, it would look like this, but we've got a top on the, we've got a cover on the top and the bottom, a circular face on the top and the bottom. Your can of soup or whatever, that would be this shape. And this geometric solid is called a cylinder. Okay, example 4 also asks us the question, identify its congruent parts. Remember the term congruent? Okay, it just means exact same size and shape. And because of that, we know that we have a congruent circular base and top. So it has 2 congruent circular bases. Okay, and as mentioned earlier, this is your answer, and this is your answer for example 4. As mentioned earlier, I want to do one more practice problem. Let's write down this for our answer on example number 5. Example 5, and I'm going to consult the rectangular prism. I'm actually just going to reuse this one. Okay, we can have our vertices labeled. And these vertices are labeled I, J. We've got H, K, L, M, N, and O. And it says, name a pair of parallel line segments. Okay, parallel line segments are all over the place. But these line segments, JO. Okay, what's parallel with JO? Well, we've got another segment over here that runs perfectly vertical. And again, those two are on the same plane. They both run vertically and they'd never touch. So 2 parallel line segments would be JO and KL or LK. Remember, the order that we put these 2 letters in doesn't matter. We want to put segment above the top just so that we know what we're talking about. Okay, we could mention MN. Segment MN is also parallel with segment LO. Segment IN is parallel with segment JO. There are more than just this option. But let's just put this down for example 5. Those 2 segments are parallel. Okay, have a good night. I will see you tomorrow.